Hello and welcome back to the NWR Virtual Healthcare Conference. My name's Matt Wright. Next up, we have Robotic Surgery Evolution, which is one of our private companies presenting today. And joining us from the company is the CEO, Adam Clark. Before we get started, a reminder that if anyone in the audience has a question, please feel free to type it in using the Q&A function within Zoom. For now, I'll hand it over to Adam to go through the slides. Please go ahead.
Well, Matt, thank you and NWR for setting this event up. I'm pleased to be here. If you can't tell by my accent, I am a recent Australian permanent resident, just moving here a year ago and had the good fortune of becoming the CEO of Robotic Surgery Evolution in April of last year. I spent the last 8.5 years prior to that as the Vice President of Sales with Intuitive Surgical, the largest robotic surgery company in the world. I ran the Western United States sales organization for them. And prior to that, spent many years at other large healthcare companies like Medtronic and Johnson & Johnson and the military before that. So ending up here in Australia has been a great blessing of my life. And I'm excited today to talk to you a little bit about Robotic Surgery Evolution, what we do and where we're going in the future. So let me get started. And real quick disclaimer about what we're talking about today. So I'm going to talk a little bit about the market and opportunity and why we are doing what we're doing and how we think and believe that we can make a major difference in healthcare. And that relates to robotic surgery is in one area. Robotic surgery is growing at a very rapid pace. It's quickly becoming the standard of care in soft tissue surgery and in hard tissue surgery across a variety of platforms globally. The market is estimated from growing somewhere from around 8 billion right now in 2023 to some estimates say 21 billion, some estimates say $30 billion in the next 10 years. And it just makes sense. Robotic assisted surgery, the surgeon still does the surgery, but the robot assists the surgeon, she or he, to be more precise. They can see better. They can have more precision, and precision, accuracy, and safety in surgery drives clinical outcomes. Up until now, the industry has largely been dominated by one or two players. But like all technology evolves and adopts with multiple competitors into the field and the space, you're going to see a much broader and rapid adoption globally. So while robotics is the standard of care, again, as I mentioned, in many surgical procedures, it's going to explode across the spectrum of all kinds of procedures. And I think that what you'll see in the near future is a robot in every operating theater or operating room across the developed world by 2030. Other key trends that matter and that drive us in our mission to reduce the need to use pigs and cadavers is that currently, when surgeons are trained, and we know that all these robots coming out need training, we know that the number of surgeons who are going through training is insulated from global macroeconomic trends. So, for example, the world needs more surgeons, period. Developed world, developing world, doesn't matter. The world needs more surgeons. This technology is advancing. And no matter what happens in a global environment, a global depression, recession, whatever, the number of surgeons needing to be trained is only going to increase. So that's a nice thing that is nice to know. But the way that surgeons learn today largely is still the same way they were learning and being taught 100 years ago. And we think that that's time to change. It's going to evolve over time. The younger surgeons of today are much more adept with technology. They have much higher expectations for what they use in surgery, the latest and greatest technology. And we're going to see, again, advanced digital surgery, minimally invasive surgery, and robotic surgery adopt globally. And then this last point on the far left here is when surgeons are trained today, they either practice in patients or they learn in animals like pigs and dogs or on cadavers. And if you donate your body to science and it gets used for 4 hours in a training lab at a cost of $7,000 to whoever's paying for the cadaver, that's not a really great or ethical use of a human body who's donated their body to science. Animals I think it's probably easy for everyone on this call to understand that the use of animals in surgical training, it's used because it's been effective, but we believe there's a better way forward on a different type of a platform of synthetic tissue models that can replace the need to use animals and cadavers and provide the surgeons a better, what we call more linear training experience, which is progressive in their learning curve. And we think that's the ethical thing. And what I think most people on the call would agree, you're seeing that pressure globally around the ethics of using animals. So you can see on this slide just the total number of surgeons out there that are in training or getting trained. And so as robotics advances, as minimally invasive surgery advances, there are tens of thousands of surgeons who need a new and better way to access training. So one of the big things I'm going to talk to you about today is our synthetic organ portfolio. One of the challenges, you'd think this had been done already, and there are companies who make synthetic organs, but one of the challenges that we see is that there are companies who make synthetic organs that look really real, but they don't perform in practice surgery like real surgical organ, like real human organs. Then there are other models that don't look real, but they actually do perform well. What we're trying to create is the combination of the two of them, which is organs that look real, are anatomically correct to the procedure the surgeon is attempting to learn, and they react the way that real human tissue reacts. So looking, feel real, and going there. So again, the number of surgeons that need to be trained on any technology is only going to increase regardless of what happens to the market. The way that surgeons have historically been trained is a 100-year-old model called Halstead's model, which we believe is outdated and will be evolving towards a more progressive and newer way for newer surgeons to learn. And the days of using pigs and cadavers in training, we believe, is numbered. And we see that trend. Companies like the medical device industry and academic hospitals across the world are struggling for solutions to find viable options, and companies will solve this problem. We intend to be at the forefront of it. So our three revenue pillars that we're focused on the far left, it's these Pindari multi-use synthetic organs. It starts with our Pindari torso trainer, I'll talk more about in a minute. It's a CT scan of a real human patient converted to this anatomical sort of synthetic cadaver, if you will. It gives every surgeon practicing on it the experience of operating on a real patient, and gives them the fidelity that they would like to have as if they were doing a real surgery. So even in a practice environment. We're also creating a whole host of content, e-learning platforms for online surgical education, so surgeons can do self-paced. Some of these videos are in 3 dimensions so that people can watch and see what the surgeon sees in the console when they're looking at 3D surgery like a robot surgeon would do. And then we also provide courses here in Victoria at our facility, the IMRA facility here in North Melbourne, right by the Royal Melbourne Hospital. So we teach courses, we partner with the medical device companies, Intuitive Surgical, that is run by Device Technologies here in Australia, as well as CMR and Medtronic. And we provide a lot of the education material for Medtronic Inc. And of course, we'll be looking to bring more and more robotic companies online to provide these face-to-face training sessions here in Melbourne. Again, the unique things about these models that we're making, that they react like real human tissue. So if you notice that skin, it feels like real skin when you touch it. And so I'm going to play a real quick video to give you a little bit more insight as to what that looks like. This is the original prototype we call Project Rhea. And so she was built on a small female model. We have a much larger version of this, which is a bit larger and more realistic. You could see the rib cage inside the model, and these are placeholder organs. The idea here is that this is a sort of a razor and blades model, if you will. The razor is the torso, and the single-use organs go inside of it and are used one time and then disposed of. All the products are tested for toxic plume, and they're all safe and effective bioinert materials. So you can use them anywhere. You can train in an operating room in Darwin if you want to. You don't need to have a surgeon fly to Singapore to a training lab or fly to Sydney or Melbourne. You can do the training in Tasmania, you can do it in Texas, wherever you want to do this, you can do the training. It's scalable. And that allows for sales representatives from medical device companies a lot of flexibility, but allows academic teaching institutions more flexibility as well. A lot of teaching hospitals all across the world have training centers, but they're not located in the four walls of the hospital. So getting surgical residents or registrars to go down to the training lab doesn't always happen. But if you could take the training to the surgeon, because it's not animal tissue, it's non-toxic, it's safe, and again, it's not made from any animal, so it's going to give some greater flexibility for the surgeon to train. In this video is our founder, Professor Tony Costello. Professor Costello is one of the first surgeons to do robotic surgery in the world, and was the first surgeon to do robotic surgery in Australia. Got the first robot here in Australia in around 2002, 2003. And subsequently, before he just recently retired, he'd completed about 2,300 Da Vinci surgical procedures. So he's one of the leaders in the space. I'd like to show you real quick an example. So if you're, this is not too graphic, but I do want to show you an example of one of our tissue models. This is a kidney with a tumor embedded in it. This is based on the CT scan of an actual kidney with a tumor. And so this is a procedure called a partial nephrectomy. It's when you remove a tumor off of a kidney, you don't have to remove the entire kidney. One of the major problems in society is that too many kidneys are removed. You only have two of them. And so if we can do more partial nephrectomies, we can save more kidneys. Fewer people eventually have to go on dialysis. And that's a meaningful impact on the world. But in order to train on this procedure, you have to learn how to do this really well. You've got to take out the tumor, and you've got to make sure that you don't leave any cancer behind. And you also need to do it in a very efficient time period because it's a time-based procedure. Well, I'm going to show you this. Oops, excuse me. I'm going to. Get back for a moment. So I'm going to show you why this matters and the research that we've been doing here in partnership with the University of Melbourne and other research partners that we work with. What you're seeing there is a surgical instrument using electrocautery or diathermy, as we call it here in Australia. And this is charring and cauterizing the way that real human tissue chars and cauterizes. And so that's a very unique feature that other surgical models don't do. When I showed this to people from medical device companies or from teaching hospitals, they're blown away with the realism of these models. And we make these models here, as I mentioned, in Australia. So the torsos are made here in Melbourne. The models you see in that video are produced up in Sydney and will be exporting around the world. We currently sell here in Australia. We've been doing a soft launch and beta testing in the United States and key academic hospitals and with medical device companies. So this is what a kidney actually really looks like on the inside if you were to remove a tumor. And then, of course, the surgeon has to close that. So she would be closing that defect. And again, for the surgeon who's training, it's all on time. They practice this procedure and they learn the essential skills. So it's not identical to the actual procedure, but it allows them to work on the procedure steps the way they would normally do. And the feedback on these models has been overwhelmingly positive. So on the product side of our business and our strategy, we sell, and I took the pricing off of here and masked it for you, but the torso trainers, again, a reusable, fully insufflatable, minimally invasive trainer. For those of you who are not in the medical community, you might not realize this, but if you've ever heard of keyhole surgery or minimally invasive surgery, what they do is they put little tiny ports into your abdomen. And currently what surgeons use to train in simulation is basically it's a box with holes in it. It's not very realistic. Surgeons hate training on it, and it doesn't provide the complete experience. What we're building here is a fully insufflatable, reusable, self-healing torso. Nothing like this has ever been created before. We have a patent pending on the synthetic material that's on the top. Again, it's resealable and rehealable. Then we have and that's a hospital or a medical device company will buy those. We have a female right now that's got complete anatomically correct with natural orifices. We're creating a male at the moment, and that will be released in the next few months. We also create these single-use organ models. Again, I showed you the kidney model. We have uteruses, we have hysterectomies, we have inguinal hernia, ventral hernia repairs, which are very common surgical procedures. We're working on colon resection for colorectal cancer, which is a very fast adopting minimally invasive procedure. So we have a whole portfolio of minimally invasive procedure organs. So those single-use organs fit into the torso trainer. And then we're building out a repair and refurbish model. Over time, after many uses, the skin will need to be repaired and replaced. And so we've got a repair and refurbish model, a business model together for our customers as well. The margins are very good, even manufacturing here in Australia. We plan to build redundant supply chains in other countries around the world, most likely the United States and here in Australia for now, and then we'll expand as we see European expansion and growth over time. So these are some of our surgical procedures that we now do. As I mentioned before, we've got these 3 revenue pillars: in-person education, online education, and the models. They really all fit together. It's a symbiotic relationship between the 3 because it's not just a course that you take in person or online. We believe in not using pigs and cadavers in training courses. So we've developed these models to be a part of it. And so you, for example, might sign up to take one of our courses. You do an online course. Right now, we just recently finished a kidney cancer course with a local world-renowned surgeon from here in Melbourne. And we'll scale that course around the world. It'll include videos of him doing surgery. It'll include him teaching other surgeons how to use our surgical training models from Pindari. And then if they want to, they can come in person to our lab and actually do the course here in person and be trained by world-renowned surgeons. These are some of the milestones that we've accomplished so far. We've been working with the state of Victoria to launch Grampians Health in Ballarat, in combination with Device Technologies and Intuitive Surgical, and thank them for their support and partnership. We've got a very strong and aligned partnership with the University of Melbourne. We'll be teaching medical students next year as a part of their medical school curriculum. They'll be taking, we have 4 cohorts of students coming in next year here at IMRA to learn robotic surgery. So we're very excited about that partnership. Again, we've identified and purchased and submitted for patents for our Pindari line of products. We've got scale manufacturing capability here in Australia and looking again to expand that globally. We've been appointed by Medtronic to provide the robotic surgery education for their new surgical robot, Hugo. We're on a 5-year exclusive services agreement with the Royal College of Surgeons of Australasia. It's a really important and reputable surgical college across the world here in Australia. We're very blessed to have RACS as a partner. They've endorsed one of our courses. We think they'll be endorsing our second course shortly, and that will fundamentally change things. We're also finalizing the agreement with the Royal College of Surgeons of Ireland, one of the more progressive medical colleges around the world, and bringing a ton of value, I think, globally as an innovator. And then just recently now we're working with Mass General and Harvard Medical School. So lots of progress there. We just finished our most recent capital raise of 5.6 million. And so we're excited to now really continue to use that fund, deploy the capital to accelerate the business for the foreseeable future, and to really build a world-renowned business where we can design and make products here in Australia and sell them around the world. But most importantly, really changing the way that surgery is done. I'll just quickly highlight here, one of the things I'm really excited about is our board of directors. And because I know this is an investor conference, I would just share with you our new chairman, Scott Tanner, he's the executive chair of K & Burton Growth Ops, involved in a number of nonprofit activities. He's also a former chief operating officer and CEO of Bank of Melbourne, and was a principal at Bain Consulting. Our founder, Professor Tony Costello, a world-renowned surgeon that we're so fortunate to have here guiding us, medically speaking, and we have a robust cadre of faculty of surgeons who are teaching here at the IMRA facility, and as well helping us build content. And that's one of our true bits of intellectual property as well, is that anybody can make a widget, but we believe we make better widgets than anybody else. But more importantly, they're backed clinically, and they're clinically validated by world-renowned surgeons. And that's something that not everyone can have. David Curtin, our non-executive director, 40 years as a barrister in Victoria and King's Counsel, and has brought tremendous value to our company and our board with his legal expertise. And our two newest members, Phil Drever from Trayfork Capital. His bio is here. He's an impressive investor and one of a broad range of experiences in investing, as well as Gareth Thomas, who's run large organizations and financial funds. Both of them recently had a business they sold out on simple loans, and have done very well. So we're very excited about them on the board, and thank them. And then this is my senior management team here at the company. Again, I'm very blessed to work with some of the best and brightest minds in the field, and a diverse background of experiences. Probably not the most diverse culturally, but from an experience perspective, everyone is bringing a ton of value, and we look to expand and grow over time. Matt, that's it for me.
No problem at all. Thank you very much for that, Adam. That was very comprehensive. Once again, I'll just remind the audience, if you do have a question that you'd like to submit, please feel free to do so using the Q&A panel within Zoom. Adam, first one is, can you just talk to the situation? I know you touched on it, but just around manufacturing for Pindari, what you do, where you're doing that, and your ability to scale up should this, see the sort of adoption that we're hoping for.
That's a great question. Yeah, the models, the torsos are pretty complex to manufacture, and the trade secrets we keep very closely held. We actually have them written down and stored in a secure site so that we can make sure that only a few people actually have the secret ingredients to the unique material. So we keep that here. We manufacture in a facility just north of Melbourne. Those torsos, part of the boxes, if you will, are made by an engineering partner here, but then all the skin and material is hand done by our own team and staff. And we can scale those. Right now, we can make about 3 per week. We have obviously a lot of growth aspirations. So over time, we're looking for alternative ways to scale that. It's really just a function of forecast. So as the demand curve grows and we can forecast out, we can add the expertise to make those and manufacture them, so long as we forecast them about 90 days out. All of the single-use items, those organ models that I mentioned earlier, those are going to be manufactured in Sefton and up in the west suburbs of Sydney with our contract manufacturing partner. We have an exclusive agreement with them to produce the models for this part of the world, and they can scale. Right now, we can do about 80 products a day, scaling up to hundreds or eventually thousands. They have an entire facility and warehouse that they're ready to go. And so it's really nice because they can grow with us, and they've made that commitment to our growth. They currently make things for NASA and for SpaceX and for the Australian Navy and a whole host of other advanced manufacturing. So being able to scale products is not unique to them. and we're excited to have them as a partner. And then, as I mentioned, these are fairly heavy products that we make. So we'll be building redundant supply chains in the United States, which is the target market for most of this. The US is the largest and easiest market to access globally for healthcare. These are products that don't require regulatory approval or anything like that. There's obviously safety tests and things like that that we've all completed, but from a regulatory burden, it's a very low burden to get through. And we'll be manufacturing again in markets where we're closest to. So Western Europe, the US, and then the Australasia market.
Excellent. And you touched on it at the start of that answer, but the IP around Pindari is obviously key. Can you just give a bit of background on the history there and how you've protected the company in that regard?
Yes, thanks, Matt. One of the first things that we realized is that, the IP matters a ton because what we're doing is truly unique, and you see it in our customers' eyes when we show them. And so we have been working, it frankly took months and months and months, but we got all of the patents submitted for the skin material, for the concept of the torso and how it fits in, which is a very unique, we think, very unique model. We've patented that. And then also some of the chemical compounds that we use in the organs that make them char like real human tissue. And then we've got a whole IP strategy for our other future products that we're developing. So intellectual property is a big part of what we're doing with, we think about our product portfolio and pathway, and IP is right there all along the way. How do we do something? I don't want to try to do what everyone else is doing. I want to do what everybody aspires to do and hasn't been able to solve technically, and we want to make sure that's secured with patents along the way.
Yeah, absolutely. Next question is, how much work have you put into the US market so far? I mean, given your background and experience there, you're spending a lot of time on the ground there and talking to potential sort of partners and customers.
It's a really unique and envious situation in that I believe there's more interest than our ability to get the products ready to full commercialization. That's why we've needed the capital raise, which we just completed. And so now we're in a situation where now we can take these prototypes and our base level of model and expand the portfolio so we have a full and comprehensive offering. We're working on things like transparency, like logistics, shipping, some of the US entities that we need to set up. We hope to have those completed within the next 30 to 45 days, and we'll be ready to go and take orders. Right now, we do ship product into numerous sites in the United States and get feedback from them as a part of our soft launch. And we're working with some very prominent medical institutions, teaching hospitals, and medical device companies. Some up and coming robotic companies, some well-established global robotics companies. And as I mentioned before, these models are not just for robotic surgery. They're for anyone who's learning minimally invasive surgery. So that's why we believe they're scalable globally. And we'll look at markets like Japan and Korea. We'll look a lot at Western Europe and partnering there. Next up for us is obviously, the US and Ireland and Australia will really be the focus initially, and then we'll go. But I'm in the US at least once every 3 months, and we're about to add a chief commercial officer in the US market in the next 45 days or so. We have that person identified, we believe.
Great. And just one final one, you keep touching on my answers before I get to the questions, but you mentioned sort of funding and the sort of corporate plan. Can you just speak a little bit more to that? I know there's a couple of people I can see in the audience who'll be asking, is there an IPO on the horizon or how that might look? So can you just give a little bit of background on what the status is at the moment?
Thank you. This question comes up a lot. I'm not trying to be evasive or cheeky, as we would say here. I want to build a great company that does some amazing work that no one else can do. I believe the board and the shareholders will tell us when, and the market will tell us when it's time to IPO or whatever the exit strategy may be. But I think and believe, I'm a bit old school, I'm probably a little older than I look. I think if we build a great company and a great brand, The rest of it will take care of itself. This is not an imminent 12-month IPO. That is not the business that we're in. The investor group that just came in with us has a vision for building something great, as I do, as Professor Costello and the board do. And so for people who are interested in our company but think this is a 12-month to IPO, I don't think it's 12 months to IPO. I mean, could it be? Maybe, but I doubt it. That's not the intention. We want to make sure we create a difference in the world and also true wealth for our shareholders.
Fair enough. And that's a good note to finish on. So thanks very much, Adam, for the presentation today and taking us through the story.
Wonderful. Thanks, Matt. I appreciate it. Thanks for the time.
No problem. And that actually wraps up the conference. So for the people who joined this presentation and the other ones, thanks very much for your time over the last couple of days. All the replays are going up on our YouTube channel. So if there's anything you want to rewatch or something you might have missed, feel free to have a look there. But thanks again for your attendance.
Thank you.